Welcome to our physics circus project about kinetic and potential energy. So what is kinetic energy? Kinetic energy is energy in motion of an object, whereas potential energy is stored energy of that object when it's at rest. The conversion of these energies can be used to perform a certain task, such as fueling a person to move a certain distance. Cars of different masses and balloons of different volumes are used in our project. The cars of different masses and the balloons of different volumes are different amounts of kinetic and potential energy. The formula for kinetic energy is 1/2 mv squared, and both cars have different masses and will therefore travel a different distance despite having the same amount of potential energy. The formula for elastic potential energy calculated from Hooke's law is 1/2 mv squared. But here both balloons have a different potential energy and thus travel a different distance. The factor that is changing is the distance traveled, whether it is different kinetic or potential energy. We know the mass of our cars, the spring constant for potential energy, and the velocity because we know our distance and our time. With blocks of different masses and thus different kinetic energies, but the same balloon size, aka the same potential energy, the block with the greater mass and the greater kinetic energy would move a further distance. But with blocks of the same mass, aka the same kinetic energy, but different balloon sizes, which are different potential energies, a greater potential energy would result in a greater distance traveled. Now let's see how it works.